Let's assume that I have two different algorithms to look up a word in a dictionary. Now, algorithm A looks one page at a time. So let's assume that we're looking for a word that starts with D. So we go through the pages with A. Nope, it's not here. Just flip, look through that page. It's not here, and it keeps going until it finds that word. Now, algorithm B starts from the middle. So we would just open up the book in the middle section and see if the word that we're looking for is on the left or the right side of the middle. Now, we said the word was D, or the word starts with D. So in this case, it would be on the left side if we open the dictionary right in the middle. And we keep doing that. So from left side, now from beginning to the middle, the new end that we have. So this is the middle, and this is the beginning. So we know it's on the left side. So now we're gonna get the half of this, and we're gonna check again if it's on the right side or the left side. And we will keep doing this until we reach to the specific page. Now these two algorithms will find the word, but they will find it in a different time. So let's assume that the word is on the 100 page. So when it comes to algorithm A, it would take 100 pages to flip until we find that word. Now when it comes to algorithm B, we start with 100 pages, and then we have 50 pages left. On the next step, we have 50 pages to look. And we will keep going. We'll have 25 pages left, and it will keep going like this until we reach to one page where the word is. Now, when you look at this, we can say, so it took us 100 operations to reach to the final answer, but algorithm B right here, it took us, if it keeps going from 100, 50, 25, we can say that it takes to the x equals 100, which is about 7. So it took us 7 operations. Now, when we look at this, you can make a statement that algorithm B is 15 times faster than algorithm A. Now, according to this example, it would be right. But how about, what if we had 10,000 pages? So for algorithm A, 10,000 pages would take 10,000 operations, at worst case. These are at worst, like let's assume that it was at the end of the page. It would take 10,000 flips to find that exact word. But algorithm B, it would be 2 to the x equals 10,000, and that is about 13. So it takes about 13 operations at worst case. Now in this example, algorithm B is 770 times faster. So as you can see, it depends on what input size we're using. So clearly we can't say one is like this times faster than the other one. How can we show that algorithm B is faster than algorithm A? That's where big O notation comes up. When we tested algorithm A, if we put 100 input, we get 100 operations. And for algorithm B, it was something like 2 to the x equals to however much we put, like let's say 100. We say that let n equal to the input side. So for algorithm A, when we put input n, we get n operations in the speed of n, let's say. For algorithm B, when we put n operations, 2 to the x equals n, we get log, if you remember, logarithm is the opposite of exponents, log base 2 of n. So as you can see right here, we can get two different functions for these algorithms. For algorithm A, it would be a linear function. So something like this, where input size increases, the output time also increases, like this, in a linear way. And for algorithm B, we would get a logarithmic function. So something that looks like this, the input size increases, the output time will increase, but not as much as the linear one. To denote this, we're going to use big O notation. And for algorithm A, we're gonna say it has O of n time complexity. And for algorithm B, we're gonna say it has O of log n time complexity. This is how we write. We can have algorithms with functions or big O notations like n over 3 or 5 log n. And it doesn't matter what the constants are. You're just gonna write big O notation as just like O of n, and this equals to O of log n. And let's say you're given a function like this, n cubed plus n squared over 2 plus 6. And so they're asking for the big O notation for this function. You're gonna say O of n cubed. You're gonna pick whichever has the highest degree. Again, it doesn't matter if it has a constant in front of it or anywhere around it. You're just gonna take a plain n and with the highest degree. Here are some big O notations that are commonly found that you will probably encounter at some point. So these are ranked based on how well they do or how short it is. So O1 is constant time. It always takes same time. No matter how much input you give, it always takes O1. And we know from previous videos, from RAM model video, that operations like addition, subtraction, arithmetic operations, and logical operations like comparisons and whatnot take O of 1 time. O of log n is the next one. O of n, linear, n log n times log n, and n squared and 2 to the n is the worst one that you probably never want because it will exponentially increase and increase. And that's it. Thank you.